Okay, let's take a look at finding a vector from the direction and from the magnitude. Now we can find the vector by using the component form here. And so we have the vector v is the magnitude times cosine I, if you look at my triangle on the left hand side, plus the magnitude times sine of I. Now, if the angle theta is really tangent, it's y over x, sine over cosine. So tangent theta here with my triangle would be sine theta over cosine theta. Now, if the vector is in standard form with ai plus bj, then the tangent theta is b over a, which is opposite over adjacent. And then, of course, to find the angle, you do the inverse tangent. So let's take a look at a problem here. Let's say we have v, let me change color, green, why not? Let's say we have the vector v, which is 4i minus 4j. It's always good to draw a picture. So really, a 4i minus 4j kind of represents your ordered pair, which is 4 comma negative 4. So if we graph this, 1, 2, 3, 4, 1, 2, 3, negative 4, then that just means when we draw a vector from 0, 0, we go to 4, negative 4. Here you go. So our component form is 4, negative 4, which is really our B and our A. So A in this case is 4, and B in this case would be negative 4. So to find the angle, be careful here, you are in quadrant 4. To find the angle, we have tangent theta equals negative 4 over 4, which is equal to negative 1. So the inverse tangent, theta, is the inverse tangent of negative 1. If you use your calculator, you will see that theta, let me stop for a second, let me find my calculator. So I found my calculator, and that's what I was trying to point out to. You will see on your calculator theta is negative 45 degrees because we found the inverse tangent. However, we're looking at the angle that is between 0, so theta is greater or equal to 0 and less than or equal to 360. What you have to do is to find the angle in quadrant 3. It is 360 minus 45 degrees, so the angle is 315 degrees here for theta. Let's take a look at another problem where we have our vector. We have basically, this is an application. A ball is thrown with an initial speed of 25 miles per hour. So let me draw a picture. Initial speed of 25 miles per hour in the direction that makes an angle of 30 degrees. So here you go is our vector, and we have our 30 degrees. That is our direction. Now, what is the expressive velocity vector v in terms of I and j? So v, our vector, would be the 25 miles per hour is our magnitude. So it's 25 times the cosine of 30i plus the sine of 30, and that would be, I have no more room, j. Here you go. So now that is the same as 25 times cosine 30i plus 25 cosine 30j. And then, of course, we find the cosine of 30, which is the square root of 3 over 2. And that is I plus 25 times the, and this should be sine here, times sine of 30, which is 1/2 j. So there's nothing really that we can simplify. We have our 25 square root of 3 over 2i plus 25 halves j, and these are basically our components. We have the horizontal component and we have the vertical component. The vertical or the horizontal, let me just graph this here. The horizontal is the 25 square root of 3 over 2, and the vertical is 25 halves. Here you go. So that's it. Let's see if there's another one. Let me pause this for a second. Okay, here's one more problem. It says find the component form of V given its magnitude and its angle it makes with the positive x-axis. So let's find the component form of V. We have 2 square root of 3 times, different color, times the cosine of 45i plus 2 square root of 3 times the sine of 45j. That is 2 square root of 3 cosine of 45 is square root of 2 over 2 I plus 2 square root of 3, and the sine of 45 is also square root of 2 over 2j. We can reduce here. We can reduce 2 with 2. That square root of 3 times square root of 2 is the square root of 6i plus the square root of 6j. Here you go. That is our component 4. That's it.